Welcome to the ATC Double Cut. I am going to talk about a very interesting article with an interesting recommendation that I read a few weeks ago. I saw it for the first time. It was just published last autumn, and it is about a topic that I think we're all interested in, which is cultivation or coring. And this happened to be an article about cultivation of bentgrass greens in the transition zone, which is something that I'm quite interested in. The article, the blog post that I'm going to talk about has a title of "Coring 3 times a year is recommended when ... And that is a blog post that I put up. I will put a direct link to this blog post in the show notes so you can click through to read it. And I highlighted this very interesting conclusion that the authors had. Now, the article is titled "Creeping Bentgrass Surface Properties Following Aerification," and it is by Hubbard et al. It was published in 2022, and it describes an experiment that was done in 2011 and 2012 on a Crenshaw creeping bentgrass green, and that green was it 17 years old at the start of the experiment? It was planted in 1997, and the green was 14 years. Yeah, the green was established 14 years prior to the start of this experiment, and the green originally was built in a sand and with a drainage system and everything that would let it meet the USGA recommendations. So in the article, they wrote that the green was originally built to USGA specifications. That's a direct quote from the article. So this is, let's say, a medium-aged creeping bentgrass green in the transition zone. This was in Clemson, South Carolina. And I gave this the catchy title, I think, of "Coring 3 times a year is recommended when ... And then the first sentence of the blog post is, "When a lot of nitrogen is applied relative to plant demand, I guess." Because I'm always interested in research in this topic about how much coring is necessary. This is something, when I was a golf course superintendent, I cored when I wanted to stimulate grass growth. When I think back on it, if we had any thin areas or traffic damage at the end of the winter, I wanted to aerify in the spring and grow some more grass back. If we had traffic areas that the grass got a little bit thin at the end of the summer, I wanted to do some core cultivation and add some fertilizer and stimulate some growth and grow some more grass. So that's the way that I used to manage, but that was 23 years ago. And I'm interested in what is working well for golf course superintendents as they manage their grass. And then I kind of adjust what I might recommend based on what's actually working. And also, I am interested in what the research data shows, because there's often numbers associated with that. And when research is done, it's done under controlled conditions. And so we know a lot of details about what happened, how much nitrogen was applied, how much sand was applied, what the different tine spacings were, and all of that. And then there's a lot of response variables measured about the turf quality and surface firmness and green speed and things like that. So we can really try to analyze what the results were and maybe try to extrapolate the results from one experiment to how we might want to manage, or how we might manage a little bit more effectively and create a little bit better turf grass conditions. Now, this one, it was a bit surprising to me. Remember, this is an article published in 2022, and the authors ended in the end of the paper. I'm going to quote now. They have this statement. Begin quote. "Overall, this study would support a recommended aerification program for bentgrass greens in the transition zone to include 2 spring hollow-tine aerification applications with 1.2 centimeter diameter tines, that's half-inch diameter, at 5.1 by 5.1 centimeter or 2-inch by 2-inch spacing, or 0.9 centimeter tines, which are 3/8 of an inch, at 3.8 times 3.4 centimeter spacing, which is basically 1.5-inch spacing. And those 2 spring applications of hollow-tine coring are recommended to happen in March and May. With that's then followed by monthly solid-tine aerification during the summer and a fall hollow-tine application with 1.2 centimeter tines at 5.1 by 5.1 spacing, 5.1 by 5.1 centimeter spacing, end quote. So after doing this study, and then they are recommending in the transition zone 3 corings a year on creeping bentgrass greens in the transition zone. Transition zone is places in the world where you can grow both cool and warm season grasses. So perhaps neither of them are particularly going to thrive, although each of them are going to thrive at different times of the year. So it's a challenging place to grow grass. It's an interesting place to grow grass, and much of the world's population lives in transition zone areas. You know, you think of places like Shanghai. Shanghai's got cool and warm season grass. A lot of courses in Shanghai have creeping bentgrass on the greens and warm season grass everywhere else. And you look at Japan. Much of Japan is transition zone. In the United States, you have a huge swath of the central and southeastern United States that would be in the transition zone. And so it's an area where there's a lot of population, a lot of turf grass, and so this is quite an interesting topic. But I was like, wow, that it's interesting that they make that recommendation in 2022, considering that that's sort of the same recommendation that was made in about 2000 or 2002, also from the southeastern United States by following up on research that was done by Bob Caro. And it's surprising to me, I guess, that this was the conclusion, because I've seen so many good putting greens, so much high quality turf that doesn't get cored that much. And I was just like, wow, that's interesting. So I read some more, because when I read a scientific paper, and I encourage you, if you're a scientist or a graduate student, then you probably read scientific papers on a regular basis. But even if you're a golf course superintendent or an assistant superintendent or a turfgrass student, you don't have to be scared of scientific papers. They're just reporting the results of an experiment. So you can just read about it, and if the authors have been particularly clear and if they've written it well, then it should be quite comprehensible. But sometimes you don't read it from start to finish. Scientific papers have a title, and they will have an abstract, which is a short summary, like a 1-paragraph summary of the paper. And then the paper will generally be formatted, or the article will be formatted with an introduction that kind of introduces the topic. Then it goes to materials and methods, which is a section that describes how the experiment was done. And that should provide enough detail in the materials and methods section so that somebody who wants to duplicate the experiment to see if they could get the same results, or if they want to duplicate the experiment so they could see what the results would be if they did this on a different grass or in a different location, there should be enough detail provided in the materials and methods section for somebody else to be able to duplicate that experiment. The next section is results, which is really the meat of the article. It's really the most important part, is what the results are. And then there will usually be a discussion section that puts those results into context. And then there's a conclusion section. So I will, depending on the article, I will often have a glance at the abstract to get an idea of what was done, because that will give a summary of each section, maybe 2 sentences from each of those sections. And then I just jump right to the results and the conclusions, because I want to see what happened, what the results were. And then if I find that really interesting, I will go back and look at the materials and methods and maybe look at the introduction. So that's generally how I look at scientific papers when I'm trying to figure out what I can take from that. So you may find when you look at scientific articles also that you jump around a little bit and you're trying to find the key parts. You may not just sit down and read that for pleasure reading and say, okay, I'm going to spend 20 minutes reading this from start to finish. Now, you will do that with articles when they're classics, when they're really good, when they're well written, when it's an interesting topic and you really want to understand everything. Then of course you read it through from start to finish eventually. But of course, them being scientific articles, they're sometimes difficult to understand the first time in their entirety. So I often end up reading and rereading and rereading when it's a topic that is new to me and it's something that I really want to learn about. So with this article with the title Creeping Bentgrass Surface Properties Following Aerification, and this is one that you can get. It's an open access article, so you can click the link that is in this blog post, and you can go to read that article. And so you can see and you can read the different sections if you're interested. So I was like, wow, I think that's a lot of coring. 1/2-inch tines 3 times a year. And if you're doing that in March and you're doing that in May and you're doing that again in the autumn, and then you're solid tining in the summer, it's like you're constantly disrupting the green. And is that much really necessary? I used to recommend like that. I used to recommend like that about 10 years ago. And now I recommend doing site specific calculations of how much is required based on the soil and grass conditions at your site. And I'll talk about exactly what I recommend at the conclusion of this episode. But as I was reading that, I was like, okay, well, let's see, is there something I'm missing about why they're getting this result where they conclude, or why they recommend that the recommended aerification program for bentgrass greens in the transition zone would include 2 spring and 1 autumn coring, supplemented by summer solid-tine applications. So I went to the materials and methods section, and at the start of that, they described how they managed this 14-year-old Crenshaw creeping bentgrass green. And they said that their annual nitrogen rate on the green was 342 kilograms per hectare, which is 34.2 grams of nitrogen per square meter, which is 6.8 pounds of nitrogen per 1,000 square feet. And I thought, maybe that does it, which is why the very first sentence of the blog post answers the thing that I mentioned at the very I mentioned in the title. I said coring 3 times a year is recommended when ... when a lot of nitrogen is applied relative to plant demand. Now, 34 grams of nitrogen on creeping bentgrass in the transition zone might not seem like a lot to you. And I think that always would seem like a lot to me. That's 6.8 pounds of nitrogen per 1,000 square feet. And I can tell you, when I was a golf course superintendent, I was in the transition zone. I was a superintendent in Shanghai. I was a superintendent in Japan near Tokyo, and I didn't keep track well, I don't have the records. I kept track of the fertilizer applications, obviously, not as much as I would now. But I guess I was somewhere around 20 grams or 4 pounds of nitrogen per 1,000 square feet back then. That was the late 90s, early 2000s. Because I liked the grass to grow, and we had, certainly in Japan, we had quite a busy golf course, and there was a lot of play on turf that wasn't growing in the winter. So I was happy when the grass could grow and when the grass could recover from a lot of this traffic. And then I went to Cornell University, and I did a study that was looking mostly at potassium, and I wasn't paying attention to nitrogen so much. And I definitely think that I over fertilized that grain. Now, Ithaca, New York is not the transition zone, but I think I applied something like 15 grams, 18 grams of N. And this was in 2002, 2003, 2004. So that was in the field experiment that I was doing. And I think for that climate, that's a little bit too much. And I don't think I needed to grow the grass quite that rapidly. And about that time in the early 2000s, I started looking into the paste turf growth potential, which is a temperature-based equation or function that takes the air temperature and it converts it to a scale of 0 to 1 or 0% up to 100% based on how close the actual air temperature is to the optimum temperatures for growth for the particular type of grass you're dealing with, whether it's cool season grass or whether it is warm season grass. And I used to use a maximum value of 3 grams of nitrogen per square meter, and on a monthly basis. So if you divide that by the average number of days in a month, you get something like 0.06, something like 0.06 something grams of nitrogen per square meter per day. And for those of you who want to convert into pounds per 1,000 square feet, 3 grams of nitrogen per square meter would be 0.6 pounds of nitrogen per 1,000 square feet. So I was basically saying, if the weather is absolutely perfect for growth, then the maximum amount of N I would want to supply over a monthly period would be 3 grams of N per square meter, or 0.6 pounds of N per 1,000 square feet, which works out to 0.15 pounds of nitrogen per 1,000 square feet per week. And so that's the number I used for quite a while, was 3 grams. But I noticed when I started checking temperatures around the world, I was checking the temperatures that people were growing the grass in, and then I was finding out what nitrogen rates they were using. And there were a lot of excellent superintendents producing excellent turf and using less nitrogen than would be predicted by a model that was using 3 grams. So over the past couple of years, I've dropped this down to 2 grams. So I now, for creeping bentgrass, if it's a creeping bentgrass putting green, I'm going to predict the nitrogen that the grass may use to produce a high quality putting surface. I'm going to start with a maximum of 2 grams, which is 0.4 pounds per 1,000 square feet, which, if it's perfect weather, that works out to be 1/10 of a pound of nitrogen per 1,000 square feet per week. Or it works out to be half a gram of nitrogen per 1,000 per square meter per week. So that's the number I use. And there's a really interesting article by Michael Becken and Doug Soldat. It's published in a journal called Grassland Research last year. I'm pretty sure that's an open access article too. And I blogged about that. I spoke about it on an ATC Double Cut a couple episodes ago. And in that article, they did a survey of golf courses. It's not a huge number of golf courses, but they had courses from around the world. They had from Norway, from Denmark, from Florida, from the upper Midwest. I think they had some from the Pacific Northwest. And those golf courses shared how much nitrogen they applied. So based on that, in the experiment, they said, well, what if we were using the growth potential model? What would the growth potential model predict? And then what are golf courses actually using? And they found, I think they were using 3.5 as a maximum, which is what Larry Stoll from Pace Turf has recommended as the maximum amount that you'd ever want to apply for cool season turf. And that's what's in the Pace Turf climate appraisal form, the legacy classic climate appraisal form that many people use. So I think in the article they used 3.5 grams, and they found that was an overestimate of what people were actually getting good results with. And they found for cool season greens, I believe the value that they came up with for the growth potential model to match what people are actually doing in the world on average for cool season greens, the maximum monthly N would need to be set at 2.3 grams. So that's very close. It's 30 milligrams difference between the 2.3 and the 2 grams that so the number that I use is 2 grams, and they found in their survey that 2.3 grams would match what people are doing. But I think it's perfect. I would rather like underestimate with N and or under apply, because you can always add more later. So the whole thing with these models is they're guaranteed. If you use these models religiously, they're guaranteed, I think, to produce very mediocre turf. But nobody really wants mediocre turf. People want to have superior turf. People want to have excellent turf. And so these models can serve as a great starting point to get you somewhere close to what the number should be. And then I like to evaluate how the grass is actually growing, how the grass is performing. If it's growing, if it responds exactly how I want it to that model predicted nitrogen rate, then I'm going to keep going with it. But if it's growing too fast, then I am going to cut the nitrogen rate a little bit. And if it's growing too slow and it doesn't respond the way I want to, I'm going to increase that rate. And so that's how I like to use these models. They certainly could be used for like a computerized way to manage turf, and you wouldn't have to think about it, but you also wouldn't have really superior conditions. You might have superior conditions sometime, but over the course of a year, I would expect the results to be mediocre. So I'm telling a very long story about growth potential and a very long story about nitrogen rate, just to say that I've used 3 and I currently use 2. And there's research that was published last year from a survey by Michael Becken and Doug Soldat from multiple countries, multiple golf courses, where they found that what people are actually doing today is a number that is about 2.3 on average. So some places are using a little bit more, some less. And it really depends how busy your golf course is, how much traffic you need to recover from, and how much winter damage you may have to recover from, and various things like that. So that's kind of the number that I expect people would apply on putting greens. So I downloaded the temperature data for the past 3 years from the Clemson site where this experiment was conducted, and I calculated the growth potential, And then I calculated how much N would have been applied if the growth potential model was used with a 2-gram maximum rate, with a 3-gram maximum rate, and then I calculated what the actual amount applied was, what that rate was. So if one were doing this using the growth potential model, using 3 grams of nitrogen, the way that I used to do it, that would work out to be 19.5 grams. 19.5 grams of nitrogen per square meter per year. Remember, they were applying in that experiment 34.2. What I do now using 2 grams, that would be 13 grams. And 13 grams is pretty much what you can expect if you go to Tokyo. And I often say that the temperature conditions in Tokyo are something between Atlanta and Jacksonville, which is, I suppose that Clemson may have something that is also in that temperature range. So it didn't surprise me to see that the annual N estimate using the Clemson data and a growth potential maximum of 2 grams per square meter per month came to be 13 grams. So the ballpark number that I'm thinking is probably going to be pretty normal for the Clemson area was in the range of 13 to 19.5. Of course, on a 14-year-old green, on a 14-year-old bentgrass green, I expect there to be a considerable amount of organic matter in the green, and that organic matter I also expect to be releasing some nitrogen through mineralization. So probably the N that I'd be looking to apply as fertilizer would be towards the lower end of that. Now, that's just my starting point estimate. On a extremely busy golf course or whatever, we might have to grow the grass a little bit more. And remember, the Becken and Soldat research, when they did the survey, the average maximum value that golf courses are actually using, if they're using the growth potential, if you apply the growth potential model to temperature at their site and then compare how much nitrogen was actually used, you end up with a maximum of 2.3. You have an average of 2.3 grams N as the maximum value that plugs into the growth potential calculation. And to get 34.2 annual N, to get 34.2 grams of N annually, which is what was applied in this experiment, you would have to have a maximum monthly N of 5.3 grams. So that's 1 pound, like 1.25 pounds. No, 1.1 pound, 1.2 pounds, something like that. And that is, that's a lot of N. I just can't imagine applying more than a pound of N to creeping bentgrass green in the transition zone. So this is not to criticize the experiment. It's just to put the results into a bit of a context that I can understand. And I'm like, okay, so they got the best results in this experiment when they applied that much nitrogen, which just seems about almost double what I would expect to be applying. They got the best results with 3 corings per year, twice in the spring, once in the autumn, with 1/2-inch tines or with 12 millimeter diameter tines, 1.2 centimeter diameter tines. So that's interesting. And I think, okay, so if you would then reduce the coring in proportion to how much I suggest that you might be able to reduce the nitrogen rate in that climate for that type of grass, if you reduce the coring, it would be a 62% reduction. So you could reduce, if you applied only 13 grams of nitrogen, that is 38% of the 34.2 grams of nitrogen that were actually applied. So if you did use the way that I use the growth potential model, maximum of 2 grams, per month and multiply that times the growth potential, and then that comes to be 38% of what was actually applied, so that would be a 62% reduction, then it seems like maybe you could reduce the coring by 62% also. So then it actually seems reasonable, because that's like, okay, we're basically reducing it by 2/3. So now what we get is one coring at one coring per year instead of 3 corings per year. So then it comes to be reasonable. I mean, reasonable in my mind based on the way that I see a lot of high quality turf being maintained. So it's interesting to look at research articles and kind of make adjustments like that. Now, I used to make these kind of blanket recommendations just like this article, and I used to take articles like this, take these kind of results and say, you should be coring this much too. If you want good turf, you should be removing about 20% of the surface area each year, filling those holes with sand. You should do this much cultivation. But I don't make those blanket recommendations anymore. And instead, if people ask me how much coring they should do, or how frequently they should solid-tine or that kind of thing, how much sand they should apply, I really don't want to give so much of an answer. And I just want to say, just figure it out. But figure it out by measuring the playability, measuring or keeping track of how much sand you apply, how much nitrogen you apply. If you can, keep track of how much the grass grows above ground, that's your clipping volume, and measure the total organic material by depth in the soil, and that is OM246. So if you do that, you're able to measure the below ground growth rate, you're able to measure the above ground growth rate, you're able to measure both of those in response to how much nitrogen you've applied. Of course, we're keeping track of the weather, so we can adjust for the weather at your site. And if you know how much sand has been applied, then we can adjust, we can then account for that sand when we're looking at how the total organic material has changed in the root zone. So now we can make a site-specific recommendation, possibly to do more, possibly to core more, possibly to put more sand, possibly to do more work. In fact, I was recently in Japan, and I was at a golf course where the total organic material has been going up and up and up, and we made an intervention and put a large amount of sand and punched some holes and put the sand not only on the surface but down into the top portions of the soil profile. So it's all of this clipping volume and MLSN and growth potential and OM246 stuff. Sometimes people think it's all about doing less. It's not that. For me, it's about doing the right amount. It's about doing as much as necessary to get really high quality turf. Now, apparently, if you apply 34 grams of nitrogen, or almost 7 pounds of nitrogen to bentgrass in the transition zone, you may have to do a lot of hollow-tine cultivation in order to keep that under control. But I would recommend not just applying nitrogen based on a total annual target. Don't just do coring based on a total annual target of how much you want to do. Actually measure how much the grass is growing if you can. Actually measure the total organic material in the soil and how that changes over time if you can. And you'll be able to very quickly dial in for your root zone, the temperatures, the water content, the existing organic material, the growing environment for microbes, the amount of traffic that you have, all of the things that affect turfgrass performance and the soil conditions. You will be able to have a lot of information about that, and you can then adjust the top dressing and adjust the hollow-tine cultivation and the solid-tine cultivation to get exactly the results that you were looking for. So that is the exciting blog post that I wanted to talk about today. So that is a classic ATC double cut of me just talking about why I wrote the blog post and some of the background information about it. So you will see the link to this blog post in the video description in the show notes. And in that blog post, you will be able to click through to see the article that I was talking about where they recommended the 3 times hollow-tining per year. I'll show you one more article that will show up in the related posts. Actually, I linked to this in the article too, where I put now I suggest a monthly maximum of 2. There's a hyperlink there, and at least at the time that I am recording this, the top related post that shows down at the bottom is the post that's reflections on growth rate, nitrogen, and top dressing. And that's what this now I suggest links to. So if we go to that and look at that post, reflections on growth rate, nitrogen, and top dressing, that is one where I had a 10-point list, a 10-point list about how I've changed my mind about nitrogen. And I put a link to that Michael Becken and Doug Soldat article also. So a lot of my soliloquy in this episode where I was talking about nitrogen rates and talking about linking nitrogen to clipping volume and talking about some of the research on that, how I've changed my mind, what Becken and Soldat found in their survey. I think you can read more about that and learn more about that in that particular blog post. So a wonderful thing about the internet is the ability to let's see. Can I put us side by side? Nice. Yeah. So a nice thing about the internet, I'm just playing with my screen here. For those of you listening to this, I think I'm going to make a fancy thumbnail. And so I'm showing a picture of cores on a green on half the screen, and I'm showing myself on the screen, and I will put up the ATC double cut with Micah Wood's little note on the screen, and maybe use this for the thumbnail image for this particular episode. So, if you're interested in any of that background information about the nitrogen rate, you will find it in that post, and hyperlinks are pretty cool because all of this information is all like linked together. So the growth rate is linked to how much organic matter gets produced, and the work we do to manage the organic matter accumulation or the organic material accumulation, that also is related to how much growth we need to have in order to produce a really good playing surface. So all of this stuff is fascinating for me. I'm glad that you have listened through to the end of this if you're still here. And I think you'll find this one interesting because you will still see some research that's recommending things that might seem like they're different than what I recommend. But in this case, I think the cultivation amount being recommended there is definitely because of that really, really, what I would call a really, really high nitrogen rate. All right, everybody. Thank you for listening. Thanks for watching. I will sign off now. For ATC from Yantakao, Thailand, I am Micah Woods.